wait to others to join, then we can start the lesson. Yes, welcome for our lesson for today. Welcome for our lesson for today. We are going to wind up the topic we started, that is water and hydrogen. We're going to wind up, let's summarize the topic, and we look on the main key things where that are being examined. And once we look on them, then look on the possible questions, then possible questions and how they are supposed to be answered. And we can, if time allows us, we can introduce the first topic for Form 2, and we look on the expected objectives for that particular topic. Then the topic where we are is water and hydrogen. Water and hydrogen. We look on. We started looking on water. We define what water is, and we look on the sources of water. Sources of water, and we look on the uses of water. Then under that, we look under sources of water. We say that the sources of water can be classified into two. That is man-made and natural sources. And under in each case, we gave examples. We gave examples. We gave examples. For example, we gave the sea, the oceans, the lakes, the rivers. Those are under natural sources. Under man-made, we mentioned things like boreholes and wells. Then we have also, we went ahead and looked on the uses of water. The uses of water, you look on the domestic uses, commercial use, you have the industrial use, industrial uses, industrial uses. Then we went ahead and looked on the formation of water, formation of water, whereby we say water, whereby we say the water can be formed by some reactions, by reacting some reactions there. Burning of the candle, the end product formed when an organic substance burns in air, and in that case we look on then under that we said we said an organic substance, whereby we said an organic substance, these are substances that contains carbon and hydrogen that is being combined chemically. Therefore, this organic substance, we have said an organic substance is a substance that contains carbon and hydrogen, and therefore we call them hydrocarbons. Hydrocarbons. Now, under that, we gave examples of hydrocarbons: natural gases, petrol, kerosene, and candle wax. So candle wax is among the hydrocarbons we listed, and we said once these hydrocarbons burn in air, hydrogen on it combines with oxygen to form water, and carbon combines with oxygen to form carbon dioxide. So in candle, we have two elements present. That is oxygen and carbon. So once this oxygen, carbon, hydrogen and carbon. Sorry. So this hydrogen and will combine with oxygen to form water, while carbon combines with oxygen to form carbon dioxide, and through that we have formed water. Then we laboratory test for water, the tests for water, whereby we said being given a colorless liquid, you need to carry out various tests. After carrying out the test, then you can be able to know whether a colorless liquid is water, is pure water or not. The test number one you can be able to call out is you place a drop of a liquid on anhydrous copper 2 sulfate, anhydrous copper 2 sulfate, which is a powder. Then once you pour you put a spot. Once you put over anhydrous copper 2 sulfate, then anhydrous copper 2 sulfate will change its color. Will change its color from white to blue. Therefore, the blue one, the blue solid there that has been the blue product is red copper 2 sulfate. Hydrated, it contains then you will place a drop of water of the liquid or chloride, and once you drop there, then will combine with hydrated copper chloride, which is pink. So under that you say then the last test you can carry out is to determine boiling point of water. Pure water boils at 100 degrees Celsius. Then under the atmospheric pressure of 600 millimeters of mercury. So you can determine the water. You can determine the boiling point as liquids, and it boils at 100 degrees Celsius. Then you say the colorless liquid, a colorless liquid is water. So that is how that is what by carrying out the three tests, then you can be able to identify the colorless develop. Charles Mbulu, you have a question?
Yes, I was asking,
Yes, ask her.
does
Yes,
boiling point vary with altitude?
yes, thank you for your question. Thank
Pardon
you
the
for your
question.
question.
Does boiling point vary with altitude?
Yes,
Yes, you give us the reason. Give us the reason.
because when you go at high altitude, the pressure decreases and the boiling point of water is 100 degrees Celsius at normal atmospheric pressure.
Yes, Leslie, thank you for your good for your response. You can also repeat. You can also repeat for the others. Exactly, that is good.
Boiling point is also influenced by altitude because the when you go to high altitude, the pressure decreases. So the boiling point of water will be altered because the boiling point of water is 100 degrees Celsius at normal atmospheric pressure.
Yes, thank you. Thank you for your quick uh, response. Thank you, Leslie, and thank you, Mbulu, for your good question. For your good question. Now we went ahead. We went ahead and looked on the chemical property, the physical properties of water, the physical properties of water. Before we look on that, somebody may ask you, explain why water is an hydride of oxygen. So that is actually under the formation of water by combining hydrogen and oxygen. So that is there. Then under physical properties of water, we said water is colorless, odorless, tasteless, liquid, has a freezing point of 0 and a boiling point of 100 degrees Celsius, 100 degrees Celsius at an atmospheric pressure of 760 millimeters of mercury. Then water, it also dissolves in many substances to form aqueous solution, therefore meaning it is a universal solvent, a universal solvent. Then we say water has a density of 1 gram cubic centimeter. Now, under the chemical properties of water, that is where we look on various reactions that takes place. We started looking on the reaction between water, and and uh, metals. Metals, reaction of water with metals, whereby we started looking on sodium itself. Sodium, the first metal is sodium. We look on sodium, whereby we say sodium metal reacts vigorously with water, producing a hissing sound, or we can also say that is effervescence, or bubbles are being given out. And once there is a hissing sound or bubbles or effervescence, meaning there is a gas that is being given out. So once sodium combines with water, it forms sodium hydroxide, and hydrogen gas is being given out. Then we also said if you want to test for the pop sound, the colorless gas must be hydrogen, Then if you also want to test sodium hydroxide, the solution, the nature of the solution form, then that is sodium hydroxide. You use litmus, the litmus, whereby the blue litmus paper will turn, the red litmus paper will turn blue, and therefore the solution is alkaline. All the solution is basic. We also went ahead and look on the second reaction, the reaction of water with the calcium hydroxide, calcium hydroxide. Calcium metal, that is the metal. Then definitely, it will form calcium hydroxide and hydrogen gas. Calcium hydroxide and hydrogen gas. Calcium hydroxide is a white suspension and a precipitate. So calcium hydroxide and hydrogen and hydrogen gas. Then we said magnesium reacts very slowly with cold water. Magnesium reacts very slowly with cold water. Why? Magnesium is very, very reactive. Magnesium is very, very reactive. So once you subject it in air, it combines with oxygen to form magnesium oxide. And this magnesium oxide, it is actually a coat of magnesium oxide. Now, this a coat of magnesium oxide, it prevents it from further reaction with water. And this one, magnesium oxide, will only react with water once you scrap the surface of it so that you remove the coat. Then it will react with water. Now, so from that point, we can say magnesium doesn't react with the cold water. The reaction between magnesium and cold water is very, very, very slow. And I've given you the reason, because magnesium oxide, once subjected to air, forms magnesium oxide, which is a coat, which prevents further reaction. Then we said potassium react very explosively with water, meaning the reaction between water and the phosphorus produces some heat, and that type of reaction we said that is exothermic reaction, reaction in which it is given out. Therefore, the reaction between potassium and water, that is very explosive. It yields potassium hydroxide and hydrogen gas So because the reaction is very, 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 very explosive, then we are not supposed to carry out the experiment in the laboratory. Though, if we carry out the experiment, we need to take some cautions by using very little amount of potassium metal, so that we avoid explosion. Again, you need to carry out while standing at a very far point. So zinc and iron do not react with the cold water. Rather, they react with the steam. So reaction of water with reaction of metals with steam. So under that case, we have three metals: magnesium, we react with the steam, zinc, and iron. So look on that diagram. Steam is water, but the difference there is the state symbol. The state. So steam is a gas, while water is a liquid. So we can arrange the apparatus as we said the last time. So we have some sand there. We have the magnesium ribbon. Then there. So wet sand, once it's being heated, it produces steam. Now steam is going to react with magnesium to form magnesium oxide and hydrogen gas. Gas. Uh, and hydrogen gas. So zinc, the same thing happens with zinc and iron, whereby iron when it combines with the steam, it forms triion tetra oxide and hydrogen gas. So other methods like aluminium do not react with the steam because aluminium is a very reactive metal and a very reactive metal, and once it's subjected to air, it will combine with oxygen to form aluminium oxide, and this coat of aluminium oxide prevents further reaction. Lead and copper do not react with cold water nor steam. Then we went ahead and summarized the reactivity series of metals. Whereby we said potassium is the most reactive metal, followed by sodium, lithium, calcium, magnesium, aluminium, zinc, iron, lead, and lastly, copper. Then we went ahead and looked on hydrogen now itself, whereby we said hydrogen exists in combined state with other elements, with other elements, and we gave examples of compounds, that is water, hydrocarbons, and sugar. Then laboratory preparation of, we went and looked on the laboratory preparation of hydrogen, whereby we said hydrogen is being prepared in the laboratory by reacting dilute acid and a metal. A good example, we said we have hydrochloric acid and zinc metal. So once you react zinc plus and hydrochloric acid, the product you are going to get is a salt and hydrogen gas So you write the equation there: zinc plus HCl, hydrochloric acid, zinc chloride, and water. Then you arrange the apparatus as you can be able to see there. So you see there the hydrogen gas that is being given out. There is in production of effervescence or bubbles or wheezing sound. So that one shows that the gas is being given out, which is hydrogen. Remember, the gas now we can be able to collect the gas over water because the gas hydrogen is insoluble in water, or you use what we call downward displacement of air, that is upward delivery, because the gas is much less denser than air. Therefore, we must have to allow some purpose the first few gas, the first gas just the gas should not be corrected because the gas contains other elements that were present. Then now you can be able to write the equation, and we said in this experiment, you can, if the gas is being required dry, you use various drying agents. For example, we can use concentrated sulfuric acid as a drying agent. Then we also said in the reaction, you are not supposed to use nitric acid because the hydrogen that will be formed will be oxidized to form water. So that is it. Then we also went ahead and looked physical properties of which we have mentioned, chemical properties we have talked about, and under chemical now we have also one property that is remaining there, that is redox in reduction action of hydrogen. Reduction action of hydrogen. Whereby we said when hydrogen that is passed over heated metal, then over the heated metal, then it's going to reduce it and remove the combined oxygen from it. So you can be able to see that diagram, and I told you this one is being tested in an exam. To be given the apparatus like that, then you are being asked many questions from it. So as you look on that particular question, we have copper 2 oxide, that is a copper 2 oxide metal on the combustion tube. Then once you introduce hydrogen on it, hydrogen, the reaction there now, the reaction will take place at the combustion tube where copper 2 oxide combines with hydrogen gas to give copper and hydrogen gas and hydrogen there and water, not hydrogen but water, not hydrogen gas but water. So there, if you can be able to see there, copper 2 oxide has been reduced to copper metal, while hydrogen has been oxidized to form water. So you can be able to see that equation there. So meaning hydrogen has the ability to remove combined oxygen in metals to form water. So we also went ahead and looked on the uses of hydrogen. That is manufacture of margarine. We have it's also used in air balloons. We have also manufacture of ammonia or nitric acid. And also we have it as used as a reducing agent, as you can be able to see, and the production of organic substance. So that is all about the topic. That is what we have already done there. So the point whereby we need to put more effort: reduction action of hydrogen, preparatory preparation of hydrogen, test for the gas, then lastly we look on test for water. Then you can be able to wind up the topic. So that is all about the topic. Now let's go and let's look on the questions, the way the questions are being set. Think you can be able to see the way the questions are being set. So you can look on question 2. Let's I think you can be able to see question 2. Who can try the question 2 and which property of hydrogen that is being tested there?
They're testing hydrogen as a reducing agent.
Yes, they are testing hydrogen as a reducing agent. So in an exam, you will be given a diagram, apparatus, arrangement of the apparatus like that. Then the questions you can be able to answer. Now, a minute. So one of you look on the questions and one of you can take us through the question. Question 2. You can copy the question. Meanwhile, you can copy the question. You can copy the question. Brian Mwanzia?
Yes,
Brian
I
Mwanzia?
have a question. Yes, I have a question.
Yes, you are. Yes.
The difference between and acid.
Hmm. At the
Yes.
requesent.
Yes, the
Yes.
difference.
Yes. Is there a difference between a reducing agent and a deliquescent?
Yes.
Yes. Who can try that before I give the response? Okay, yes. Yes, yes, Pilis. Before I respond to the question, yes, who can try? I've seen two hands. Yes?
A deliquescent is a substance that absorbs moisture from the atmosphere and it dissolves it. It dissolves and forms a solution. But a reducing agent, it reduces the oxygen in a substance and makes the substance become separate without oxygen.
Yes. Leslie, thank you. Leslie, thank you. Remember we did the requisite substances, in some So you can let me try to share the questions again. My internet is giving me a lot of challenge here and there. Connection is giving me a challenge, but I hope you are able to see the question. You are able to see the question. So the question you are asking is the difference between a deliquescent and a reducing agent. A reducing agent and a reducing agent. Now, when it comes to a deliquescent, we said these are substances that absorb moisture from the atmosphere and forms a colorless solution. And we gave out various examples of deliquescent substances. Now, when we talk about reducing agent, these are substances that have the ability to reduce combined oxygen from a given metal or a given substance. That is what we call a reducing agent. A reducing agent. For example, in our case, if you look on these hydrogen and copper 2 oxide. Hydrogen, it has the ability to remove the combined the oxygen from copper 2 oxide to form water. So in this case, hydrogen has been used as a reducing agent. It's going to reduce copper 2 oxide to copper metal, copper metal. So as I said earlier, you look on that reaction, we have, that is a redox reaction, reduction and oxidation reaction. Reduction and oxidation reaction. Let me write the question for you, then we can be able to look on it. Now the question that is taking place there is, the question that can take place there is, let me show you something there. Now you can see that, look on that. Copper 2, let me write this, copper 2 oxide plus hydrogen gas. We are going to get copper metal and water. So if you look on this copper 2 oxide, this type of reaction, whereby it is being reduced to form copper, that is a reduction. Reaction. Then the one for water, for hydrogen, when hydrogen combines with oxygen to form water, this type of reaction, we call it oxidation reaction. Then the whole of this reaction, we call it redox reaction. What do we mean when talk about redox? Reduction and oxidation reaction. Second, copper 2 oxide that's been reduced to copper. Then while hydrogen has been oxidized to form water. Copper 2 oxide reduced to form copper, while hydrogen being oxidized to form water. The whole of that, that is a redox reaction. I don't know how I can answer questions. So those are some of the questions you may expect. What I was saying is the same apparatus for reducing action of hydrogen. Yeah, the one I shared with you. The one I shared with you. Then where there was a copper 2 oxide, we'll replace it with lead 2 oxide. We'll replace it with lead 2 oxide. And once we replace it, then we have some questions on it. Before lighting hydrogen gas at the jet, why is it important that to drive off all the air in the combustion tube? Explain. Explain. You explain it there. So that's what you are supposed to do there is, before I respond to the question, who can try? Nimesema, the apparatus, the one I shared with you for reducing action of hydrogen. Mahali kulikuwa na copper 2 oxide, will replace it with lead 2 oxide, then sodium as well. Before lighting hydrogen gas at the jet, why is it important to drive all the air in the combustion tube? Let me share with you the questions. Now I'm sharing with you the questions. Let me share with you clear. Itakuja clear, please. A minute.
Yes.
I think you can be able to see Nasema. The diagram below shows an experiment to demonstrate the properties of hydrogen as a reducing agent. Then we have dry hydrogen, lead 2 oxide. We have it, combustion tube, flame, and the jet. Si hapo tuko sawa, you have seen the diagram.
Yes.
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 Now the questions. Now the questions. Now the questions. Question number 1. Inasema, before lighting hydrogen gas at the jet, it is important to drive off all the air in the combustion tube. Explain. Explain. Who can explain for us? Who can attempt that?
A mixture of air and hydrogen burns with an explosion. So it is important to let out all the air in the combustion tube before burning the hydrogen to.
Yes, thank you very much for your response. Thank you. It's a very good attempt. Very good attempt. Another. Now, that is good. Once that is to remove the air that was present in the apparatus, because once there is air in the apparatus, it will combine with the hydrogen. Then once it burns in hydrogen, it will explode. So that we do that that we observe the experiment. Give our equation for the reaction that causes the observed changes. See, that is first of all, you write the chemical equation. That is writing a chemical equation that takes place at the combustion chamber, whereby hydrogen combined with the 2 oxide to form lead metal and water. Sini hivyo tafadhali. You write that question, you explain your observation. Think that one is very okay. Question C, what other observation will you expect in the tube? The observation that will you expect in the tube? Under that, you look on the color, the changes that are taking place there for lead. Reducing lead oxide to lead metal. To lead metal. To lead metal. Remember, lead 2 oxide is yellow in color, but when it comes to lead metal, is silvery in color. So you can make that observation there, basing on the color. The question D, why should excess hydrogen be burned and not allowed to escape into the atmosphere? Why should the excess hydrogen be burned and not allowed to escape into the atmosphere? That is another question we need to do. That's another question. So who can respond to that?
I think it is because hydrogen has a choking smell.
Hydrogen has a pungent smell.
Choking, yes.
A choking, irritating
Yes.
smell. Yeah, that is very good. That is good. Wengine wako wapi? Let's move on to the another question. Where should the supply of hydrogen continues until the apparatus are cool? Why should the supply of hydrogen continue until the apparatus are cool? Hiyo swali imekuwa ngumu. Hiyo ndio rahisi sana. Why should the supply of hydrogen continue until the apparatus are cool? Hakuna mwenye anajaribu hiyo. Leslie.
Acha sijui.
Thank you. We have Brian Nganga. Can you try? Charles Simbulu, can you try? Godwin. Ina hiyo swali ndio iko rahisi sana. Why should excess hydrogen
to avoid the reoxidation of hot metal by oxygen from air?
To avoid the reoxidation of hot metal from air. That is good. That is good. That is good. That is good, Charles. Another one you can also say, this is just to allow, to ensure all the lead 2 oxide has been reduced. To ensure all lead 2 oxide has been reduced. You can also say to provide enough time for the reactions to be complete. Now, I'll ask the question, last but not least, name the product formed at the flame. Uko at the flame. Name the product formed at the flame. Name the product formed at the flame. The product
Water.
formed at the flame.
Hydrogen.
Water. Yes.
Teacher. Is
Yes.
hydrogen.
The product.
Is hydrogen oxide same as water?
The question is name the product formed at the flame. Uko kwa flame, hapo kwa jet. Name the product.
A colorless solution.
Yes. Which is which? Hydrogen. Another one is saying hydrogen. Another one is saying
Water.
water.
Hydrogen oxide.
Yeah.
Hydrogen burns in air, so it will burn in air, so it will form water.
That is good. The product formed there, that is water. Since once hydrogen burns in air, forms what? What the product? The question is the product. The product. Then that is it. That is it. That is it. That is it. Let me give you another question. Another question. This is another question. Let's do this question, the last question. Then I will share with you the question with Mwalimu so that you can do as a part of assignment for this topic. Nadhani mumeona hiyo vizuri sana. Nadhani mumeona hiyo vizuri sana. Yes. Sasa jaribu kufanya hiyo. Do that. Tufanye hiyo sasa.
The zinc gas, hydrogen gas is channeled to the anhydrous calcium chloride. Anhydrous calcium chloride is a deliquescent, so it will absorb water so as to make the hydrogen gas dry. So the gas collected at X is hydrogen gas.
Yes. Thank you. Thank you for your quick response. Now, if you look on the arrangement of the apparatus, that is laboratory preparation of hydrogen gas. We have zinc metal, dilute acid. Then you have anhydrous calcium, which act as a drying agent. Then the gas will be collected there. Now the question is, identify the gas X produced when zinc granules reacts with dilute hydrochloric acid. So gas X there, that is hydrogen gas. Gas is a gas. Write our equation for the reaction liberating gas X. Hiyo ni rahisi sana, whereby zinc react with hydrochloric acid to form zinc oxide, zinc chloride, and hydrogen gas. Now the question is why it is not advisable to use sodium in this method, in this preparation of hydrogen. For that, why it is not advisable to use sodium?
Sodium is highly reactive with.
Sodium reacts explosively with acid.
Yes, that is it. Thank you. Sodium is very reactive. Very reactive. What is the purpose of anhydrous calcium chloride in the YouTube? The purpose of calcium hydroxide
Absorb
for
any
the purpose
moisture.
of anhydrous to
To
absorb
absorb
any moisture, so that it acts as what? A drying agent. A drying
Agent.
agent. Name another that can be used to serve the same purpose as anhydrous calcium chloride. That is what we use.
Dilute
We
sulfuric
use
acid.
sulfuric acid. Dilute sulfuric acid. Then another question, give another method that can be used instead of zinc. So instead of zinc, we can use
Magnesium.
calcium.
You can use magnesium, calcium. Name the method used to collect the gas and give the property. The method of gas collection said it can be collected by
Upward delivery.
over water, because upward delivery, because it is less dense than air. So actually that is it. That is it. So that is it. So I think you have looked so much to questions that are being tested when it comes to this topic, that is water and hydrogen. Now what we are moving to, where we are expecting, I'm going to give you questions over the topics, many questions through Mwalim, so that you do those questions and you share with me the questions, your response. Unatuma through my WhatsApp number. Then after you send, I'll mark and respond and give you the feedback. Then notes, you just enter into my inbox and you say, I'm somebody from Form 1 and I need Form 1Q, I need notes. So unasema uko Form 1Q, so that I can send the notes to you. I'm handling many students, so you give your proper information, then I can send the notes for you, those who are requesting for the notes. Now, in our next lesson, which is next week, we are going to start a new topic for Form 2, the first topic, and that is structure of an atom and the periodic table. Structure of an atom and the periodic table. So in that, what we expect to look on in that topic, what we expect is, first you define what an atom is. So that is an assignment I'm giving you. We define what an atom is: a compound, a molecule, and an element. So we look at that now. Our major concern will be this specifically on the atom. We look around the structure of an atom, the theory of an atom. How do we the scientists who came up with the atom? Then we look on now the subatomic particles in an atom. Then we move on to look on the atomic number and the mass number. Look on the isotopes. We look on the energy levels and electronic configuration. Then we also look on relative atomic mass. Then we look on the radicals. We look on the valencies. And lastly but not least, we look on the chemical formulae, the chemical equations, balancing of chemical equations, the periodic table. So hiyo unit, the first topic itakuwa imeisha hivyo. So itakuwa imeisha in that way. So meanwhile, my dear students, these questions, the way you have seen the questions are being tested under this topic, water and hydrogen. That is the same way the questions being tested in key. And the points where we have put a lot of emphasis on it. In each topic, the way we used to do, the point where we put a lot of emphasis, that is a point that is being examined in an exam. That is the point that is being examined in an exam. So keep on reading and reminding yourself and reminding. So that is all for today. Unless you have a question. Kama kuna swali, just ask the question. It is now your turn to ask the questions. There is a point whereby you need clarifications. You just say, we clarify that point here. So, and if you be prepared, in our next lesson, we are going to start Form 2 work. Form 2 work. As usual, you read ahead.
So you have
Yes?
phone number.
Brian, my phone number.
Yes.
You can write 0791 395 404. So once I send the assignment,
Teacher, please repeat.
an assignment 0791 395 404. So my dear students, once you need for some notes, just WhatsApp me. I will send it. Then I will share the notes with you. Once I share with you the assignment, Mwalimu shares with you assignment, then make sure you do that assignment. Then you send the feedback. Unatuma tu you via my WhatsApp, my inbox. Unatuma. Then I'll go through the assignment. I mark as usual. Then I'll give you back. I will give you back the response. So that we can move very fast. Another question, if you have a question, ask uliza swali tena. Godwin, ask a question.
She don't have a question.
Yes. Ongoto, ask a question.
No question.
No question. So you are very much okay. So if you are very much okay, I'm going to share with you now the assignment. Then you do that assignment, you send via my inbox. Then next lesson, you as usual, you read ahead, structure of an atom and the periodic table. The first topic, form 2. That is where we are going to start. So otherwise, wish you very well, and you can enjoy your day.